Greetings and solicitations. This is probably going to be the first video in a series on a virtual machine using KVM. I'm probably going to throw some Proxmox in there. That's a sort of a different explanation, but we'll get to it. New Year's has come and gone here in the Philippines. Been playing around with some lighting, trying to do some improvements. I like to do my recording in the morning because it's really cool and well, I don't mean cool, I mean cool temperature wise. And it's quiet. Usually around here, there's disturbances going on all day long, so it makes it kind of hard. Anyways, like I say, lots of projects going on. I'm gonna throw a fireworks video in here from our New Year's celebration, but after that, we're gonna jump right into the video, okay? And thanks for being here. Thanks for watching. Okay, let's start this off by a little discussion about the hardware we're going to be using. I'm using consumer grade hardware. This is a B-Link Series 6 Max Commercial off the shelf or COTS mini computer. It's got a processor, it's a Ryzen 9 6900. It's 8 cores, 16 threads, 32 gigabytes of RAM. It came with a 1 terabyte hard drive, but I also installed an additional 256 gigabyte drive. These are NVMe M2 drives. Before jumping ahead too much further, we need to really talk about the difference between commercial grade or consumer grade servers or enterprise grade. I'll use these terms interchangeably, but the consumer hardware will generally have better specifications, performance for the same price point. However, your enterprise or server hardware is going to have higher durability, a longer life cycle, a greater fault tolerance, and they do things like support redundancy to avoid crashes. You don't really, well, I don't really need server grade hardware. There's nothing really critical on my LAN. My protection is doing regular backups. I mean, I could build a server rack. I could find a space for it and acquire the components. At some point, I might actually do that just to do it just because, but right now I don't have a need for it, so it's just a needless complication. So let's take a look at this V-Link. The front ports on it, we've got a power button to the right, a USB 3 is next to that, and then it's a USB 3 Type A and then a USB 3C port. Then we got a headphone jack, and on the far left there's the pinhole CMOS reset. Looking at the back of the computer, we have another headphone jack on the right side, and we have a USB-C above that. And then just to the left of that, we have our Thunderbolt C port and a HDMI port. Then next to that is a display port, then a couple more USB ports, and finally our 2.5 gigabit LAN port. So we've got a decent selection of ports, not the best I've seen, but for a mini computer, it's decent. We flip the unit over and look on its bottom, we can see the power connection port. This is a custom job port. It's a magnetic mount. It's unique, which is sort of an issue in the case of this computer. The power adapter I got with the computer is a single region power adapter. It was 120 volt, which works great in the US, but it's 220 volt here in the Philippines, so doesn't really work unless I get a step down transformer. On the other hand, I can power the computer through the Thunderbolt port, and I do have a 100-watt power supply. That's 20 volts at 5 amps, which is the maximum for that port type. But yeah, I use that to power the computer right now. Thought it would be nice if the manufacturer who had this custom magnetic mount actually put it on a barrel connector so you could swap out adapters when you needed to, but they didn't do that. The next thing we're going to want to do with this is we're going to want to install an operating system on it. I'm going to be using Debian 12 since this will be a virtual machine server. Stability is more important than having the latest greatest hardware. We've talked about doing the Debian 12 install before, but we'll just quickly walk through it here. This is actually simulated on a VirtualBox virtual machine because it's kind of hard to get these pictures from the mini computer. I've tried to make it as similar as possible. So select our language first. This will determine the regions where the language is used. In this case, we're going to select the Philippines because that's where we are right now. However, this pushes us down to the Philippine keyboard. Didn't know there was a such thing, but we're going to go up and get American English for our key map. And then we're going to pull some components. I'm using the net install, and we're checking for our Ethernet link. This is where the process is going to vary a little bit. Once we have established our Ethernet link to the internet, we'll come to hostname. We're going to actually go back. Because this is a server, we want to do some manual configuration, and this is the easiest way to get to it. So we'll select an IP address within our local LAN. That looks good. It's outside of my DHCP range. Net mask, gateway, and name server address. Now we're back to host name, and we can give this computer a name. We don't have a domain. That may change a little later. So leave that blank. Then we have the root password. If you don't enter a root password here on Debian, it will create your first user with sudo abilities. If you do enter a root password, sudo will not be loaded. So we are going to use a root password. We will have an active root account. And we're going to have to load sudo ourselves later. Sudo is the program, for those who don't know, that lets you access admin commands. So now we create our user. This is the normal user who would normally not have access to admin functions. This is basically for our own safety. Because as root, you can delete your whole system, no problem. When you're using sudo, you usually got to think about something before you do it. Next, the installer is going to set up the clock, synchronized to a time server out on the internet someplace. For some reason here, this was taking a little while. I actually had to go in later and adjust the time servers to some in the Asia Pacific because I think it was looking for US time servers initially. It found them, but it took a bit. Once we get our time server set up, we're going to load the partitioner and set up our hard drives. We're going to do a manual setup. I've actually added 2 virtual drives to this configuration, so it's more similar to the actual computer we'll be using. Obviously, the drives are a lot smaller, but first thing we're going to do is partition our drives. This is going to be a GPT install, so we are going to need a UEFI partition. EFI partition. It'll be on the first drive. This is where our boot information will be stored. It doesn't have to be that big. It's only, I'm going to make it 512 megabytes here. And we will need well, we don't necessarily need, but I'm going to go ahead and add a swap partition also. Since this is a server, like I say, we can argue the use. This isn't the place. I put them there because they don't take up that much space. You may, depending on your situation, choose not to add a swap partition. Now we'll create our root account on this drive, or I should say a root partition on this drive. And then we'll finish off with a data partition after this. A lot of times when I'm building servers, especially like those exposed to the internet, I'll separate out the temp and the variable folder. I'm not doing that here. Again, depending on how things go, I may come back for a rebuild. Creating this partition so it ends up in the fs tabs file. That way, if I need to move it around, it's easier to change. I just need to change the folder it points at in the fs tabs. On a second drive, we're going to just have 2 partitions. One of them is going to be a swap partition. Swap actually runs faster if you have it spread across multiple drives. And then the rest of the drive is going to be for data. Same thing here. This just makes sure it ends up in the fs tab file. So if I need to modify it, all I need to do is change the address or the directory it's pointing to there, rather than enter the whole fs tab line, which in some cases can get kind of complicated. Probably not in this case, but it can. Write our changes to our disk drives. Yes. Now it's going to install the base system. How long this takes will depend on the computer you're using. It should usually be fairly quick. If you're operating without internet connection with Debian, you can download additional CDs with additional programs on them. Once we finish installing the base system, it'll ask us if there's any additional media to read into the APT system. APT is the package handling system for Debian and all Debian-based distributions like Ubuntu or Mint. Debian's the granddaddy of them all, or the great granddaddy maybe. So we don't have any additional media since we're already pulling files from the internet when we need them. Now we need to choose a region for a mirror to download software from. It helps if it's physically close. Taiwan, I think Thailand, because we're in the Philippines. Yeah. And then deb.org, we don't have a proxy. Now configure our package manager, again, that's apt. You could also use Aptitude, that's the other package manager available. I used to use it all the time, but now I just use apt. Aptitude gives you a visual display. Well, an in-cursive type display like we're looking at now, which lets you see the packages, but apt is just a straight command line interface. And we're not going to participate in a popularity contest. That's default no. I actually did say yes on a couple computers. It's not a biggie. Now we want to come through here and task select and remove all tasks from this computer except for standard system utilities, and we want to add an SSH server. Everything else should be unmarked here. No desktop, no web server. And then we'll get the selected software install. I believe it's at this point it's also doing a software update. Now we're going to install the bootloader, which is Grub in this case. It's the default bootloader. There are other bootloaders you can use, but Grub is the default for Debian. It's funny is we're actually going to go through this again when we create a test virtual machine. We're going to create it in Debian, so it'll be Debian running on Debian. Anyway, it's time to remove our boot media and hit continue to boot up into our fresh new Debian system. After this, we'll be switching from VirtualBox back to the real console because I'll have SSH in and then we can actually easily record commands and things. So that's the next step. So here we are, SSH. We're going to check our IP address. And we can see here, this is the one we assigned dynamically, or I should say we assigned statically, so we know that took from the install. You can't log into SSH as root, so we're going to have to use an su tac-l to switch to root. The tac-l gives us our root path and our root variables, so it's actually acts like a root command. If you don't have that in there, some commands might not work without full paths. First thing you always want to do on any new system is you want to update it. If we're all up to date, you don't need to do the apt upgrade. Next, we're going to install sudo so we can use our default user's account for some admin work. We're going to check our vi sudo file. This will open up in Nano by default, which is one of the command line text editors that Debian installs. We want to come down here and verify that our sudo group is active in the file, and it is, as you can see here. So this is loaded up correctly, nothing to do here. We'll just close out. Now we need to add our default user to the sudo group. So we use user mod and then -a for add, capital G for group, the name of the group, sudo in this case, and then our user. And now our user is part of the sudo. You can double check that you're in the sudo group by checking this group file in the etc directory. If you're having trouble finding it, you can add a grep command for sudo. And we can see here we've been added to the sudo group. All right, let's go ahead and reboot here just to make sure everything takes effect when we log in again. Okay, we're back. Logged in. Let's double check and see if sudo works. We'll use the dash small v. Should ask for our password. Yes. We'll enter our password. If we don't get any errors or nasty messages, then yes, sudo works. If you want to know the actual version of sudo installed, use a capital V. Next, let's take a quick look at our fs tab file. We'll use the cat command since we don't want to edit it at this point, and we can look for our two drives we added, server local store and server VM store. Yes, they're there. So they're really easy to change if we need to move them around. The UUID is already entered and the parameters are already set up. If we need to move them, all we have to do is change the directory location. We can now look at the virtualization if it's enabled. We should have already checked that in the BIOS, but we check that here using either egrep or grep. It's going to be stored in a folder called proc/CPU info. What we're doing is searching the file for a couple of keywords: VMX for Intel-based virtualization, SVM for AMD-based virtualization. This is just going to count the occurrences in this file. If there's no occurrences and virtualization has not been set up in your BIOS, it'll tell you the numbers. If it's other than 0, then yes, it's been set up because it occurs in this file. You can also grep for either VMX or SVM and get the same information basically. Like a lot of things in Linux, there's a whole sorts of different ways to do things. We could verify this by looking for the Intel information, and we should get no print back. And we don't. So this works also. Like I say, you can actually go in and look at the file yourself if you want. Again, Linux, lots of different ways to do things. And here's what the actual file looks like. It's a pretty long file though, especially considering we've got so many CPUs. Next, we need to add some additional packages we're going to need further down the line. I've actually had to come back to this section a couple times because I keep forgetting a couple, but initially curl, wget, and smartmon tools are what we're going to install initially. Like I say, I kept coming back to this because I realized I forgot packages. So we installed a package called GPG, which works with encryption keys. We're going to need that. You'll see shortly what we need it for. Next one we're going to need is bridge utilities. Again, I found out about this one way further down the line. Depending on what you install in Cockpit, you may or may not need this package. If you're going to track historical data of your processor, RAM, disk access, stuff like that, then yes, you're going to need this package because it's used by that module. It's not in any of the dependencies, so if you have errors when you're trying to load up historical data or save historical data, you need this module. I think that's what we need, all we need for right now. Next, we're going to add the repo for the 45drives.com. This repo has a lot of additional Debian packages for Cockpit. We use the tacq command for quiet and wget. The O and the dash will send whatever file we get to standard out. We're going to pipe that into GPG to decrypt, expand it, and then the dash O option here will save this to an actual user file. So this should be quick. Yep. Next, we want to go ahead and change over to our etc directory and our apt sources list.d. If you ever read your sources.list file, it references this folder and to run all the files in it. Any non-standard repositories should be put in this folder, not in the sources.list. So once we're there, we're going to use the curl command, small s for silent, large S for showing errors. We're going to download this source and we're going to write it to our directory there. So if we do an ls command, we can see it's there now. And before we do an apt update, let's take a look inside this file. And as you can see, it just gives us another repository. Okay, before we do an update, we're going to take a look at the available Cockpit packages in the standard Debian repositories. We'll use apt list for that, and we'll send that through grep, searching for the word cockpit in each line. And these are your basic 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 files. Now we'll go ahead and run an apt update. So we'll get information from the new repository we added. There we can see it hit the two repositories and downloaded information from them. Now let's go ahead and repeat the last command and see how many cockpit files or cockpit packages are actually in our apt list now. We got quite a few more, and several of these we're going to be using. Some of them you don't want to use, but we'll talk about the ones I want to use anyways. Before we get around to any of this other stuff, we need to verify our hard drives or the smart data on our hard drive. So let's first do an ls block to see what drives are there and what they're called. And we can see our main drives are NVMe 0 in 1 and NVMe 1 in 1. These are going to be in the dev directory. So smart control sudo, we need sudo smart control dash a, yeah. Well, this isn't going to give us anything, is it? No, we need to add the dash a option. Yeah, David tells us that. Use smart control dash a. So sudo smart control dash a.
and then dev, and then our drive name. We're going to check both drives before we go much further. And we'll get a lot of information. The big one we're looking for is the Smart Overall Health Assessment test results, which in this case is passed, which means the drive's good, at least for now. We're going to check both drives. And the other one passed as well. All right, next thing we're going to do is actually install Cockpit. So we'll do our sudo apt install Cockpit, which is the base package. Once we install this, we're going to go back and take another look at our Cockpit list from our apt sources file. This installs the base package, but also installs some dependencies, so some of those files will already be loaded for us. Again, speeds of these downloads will vary depending on your network speed. So let's take another look at the Cockpit files, or packages. I want to call them files, they're packages. Okay, we can see several of these have been marked as installed now in addition to the main Cockpit package. As I said, these are dependencies, so they'll be automatically installed. So what we're going to want to do now is we're going to close our SSH session and we're going to try and log in with our web browser. So that's the next step. Okay, let's open our web browser and we're going to go to our IP address, and the port is going to be 9090. And we're going to get a security warning. We went to this site, we set this site up so we can go ahead and say advanced. And now it's going to tell us that the problem is that Cockpit uses the self-signed certificate and it doesn't like it. We can go ahead and accept the risk and head on into the Cockpit interface where we come to the login screen. This is our normal user account we created. And we're here. You see this little sort of teal blurb here? That's the one that appears when you log into Linux. Normally, you can go ahead and just close that. We've got some problems with our time server we'll look at later. Right now, we'll just take a quick view of the interface. There's our log files. You see we had some errors. We'll deal with those a little later. None of them are critical. Actually, they're warnings, I think. They're not errors. Yeah, warnings. See, there's our time server. We changed that to Asia instead of the US. So we'll see if that syncs up now. There's some various system information from the system information box. Like I say, take your time, poke around the interface a little bit, see what's here. There's a lot of information. We will be, yeah, these are warnings. We will be looking through some of it because we're going to be using it. Oh, these are group permission warnings. Anyway, here's our storage pools. You can see all our drives we formatted for storage. Over on the right, we can actually see the two drive names, and NFS support is installed by default in Cockpit, and RAID support is installed by default. Networking section, our network adapters, our user accounts, our running services. Like I say, just poke around the interface a bit for yourself and see what's here, what's not. We're going to be adding a bunch of stuff to the interface. These are additional programs that were automatically loaded when Cockpit loaded up. We can actually software update from inside Cockpit, but we're up to date so we don't have to. And you have a terminal available within Cockpit. So let's go ahead and add some more packages. Yeah, more packages to Cockpit. More is better, right? Again, these packages are just going to increase the capabilities of the interface. So let's go ahead and do an apt install. We need to use sudo. I've got to keep reminding myself of that. I remember for the longest time when I first started using Linux, I did everything as root. I say that's a security issue. You can also really bork your system. I've done that a couple times, so sudo's definitely better. Sudo apt install cockpit dash. Look through the list here. Okay. File sharing. This adds SMB support so you can make a network folder. Cockpit identities. We had a accounts, but this gives us the ability to do a little bit more, specifically create a Samba password. Cockpit Navigator is a built-in file navigator to the Cockpit interface. PCP, Cockpit PCP, this is what we're going to use that XY or XZ utilities folder for, and it allows us to keep a record of our server hardware data. And then Podman is a container program similar to, oh man, I wish I gotta get the fat fingers, but Podman is similar to Docker. Yeah, it's like Docker. Still fat fingers. All right. Oh, I'm missing a T. Okay. As I get older, my fingers get fatter. All right, that's done. Now we see we got a lot more programs installed. Oh, we forgot Cockpit machines. That's what actually gives us virtual machine control through Cockpit. Yeah, got to make sure that one gets installed. And that's a big one because it's going to add KVM and libvert and some other stuff. Yeah, our virtual machines wouldn't have gone very far without that. Okay, I think we've got everything we need now. Let's just go ahead and reboot. All right, back in the cockpit after the reboot. You'll notice our left-hand menus are extremely expanded. We got a lot more options. At some point, we'll take some time to explore those, but not right now. Okay, virtual machines. Let's see, we've got a network. We got to make sure that's active. Let's see. So, yeah, we want to do something first. We want to use our, well, here's our navigator. You can see it's the file browser, basically. What we're going to want to do is set up an SMB share so we can upload an ISO file to, or, oh, misconfigured. Oh, yeah. Luckily, Cockpit does that for us automatically. There's a specific entry that needs to go into your Samba configuration file. But before we do that, we need to go to identities. First time you run, it's going to take a bit to load. Users. See, this is our normal accounts. But what we want here in identities is if we select our users and we select my account, and if we scroll down, we can see set Samba password. That's what we want right there. Okay, before we get too far ahead of ourselves, we need to fix some errors, which means we need to add ourselves to some groups, specifically KVM and libvert. Yeah, that's where some of those errors are coming from. As a normal user, we can't really use either libvert or KVM without being part of the group. If you actually read the some of the install stuff for it, it'll tell you that. So now I'm part of the KVM group. I'm going to make myself part of the libvert group real quick, and then that should clear up some of these errors. Let's go ahead and see after I've finished modifying the groups. We'll see which groups I'm actually a member of. There's other ways to do this. I just, like I say, different strokes for different folks. Choose your method. And I'm a member of both libvert and KVM, so I'm good here. Okay, next. I'm going to download the Virtual Machine Manager Vert Viewer. We're going to try and use that later, not right now, but I thought I better mention it. This is what basically lets you do a remote into your virtual machine from your desktop. We're going to download the Windows x64 version for the OS we're using. We're also going to download the Linux version. Well, we get the Linux version from the repository. So anyways, we create our Samba password. This creates a sample account for our user. Then we're going to go to file sharing and we're going to create a shared folder over SMB that we can open from pretty much any computer. So we're going to put our ISOs in this share. And it was at server, yeah, there. Okay, and I'm the valid user. That's good. And we should confirm this. And there we have our ISO share. And if we jump over here to our Windows computer, we can map a network drive. And then we can just transfer files back and forth between the two folders. So you can see the network drives here. And there's the same folder that's, or I should say the same file, the ISO image that's in, that we copied over. It's just an easy way to get things on the machine. All right, back to virtual machines. First thing we want to do is create a storage pool. And that was in server, local store, ISO images. Okay, we have a storage pool for ISO images. Yeah, let's go ahead and create one for VMs now. You had to activate it. This one's VM store. And we need to activate it. All right. I think we're to the point where we can actually try and create a virtual machine. Our network is active. So create VM. Unique name, Debian 12 base. Okay. We're not doing an automatic install. We want this to be a system machine. Our ISO image is, well, you'd think you made this share, you could just click on this share. Server, local store. What was the point of making that share now? Well. Oh, no, Debian 12. Well, I think this doesn't really matter other than setting up some base parameters. So we'll just go with bullseye, Debian 11. Create new volume, VM storage. What is going on? Lost and found. Let's do new volume, I think. We'll make a folder, images, okay. And instead of lost and found, we'll put it in images. No, we'll just use create new volume. Storage limit 10 gigabytes, memory 1 gigabyte. Let's give it 2 gigabytes. No, 4 gigabytes. Okay. And 20. And create and run. Okay, it says it's running. Let's go ahead and click on our name. Okay, and there's our console. And we can actually do things in the console, so that's cool. And let's just rush through this Debian install pretty quickly because it's the same as it was before, basically. Well, for the most part. And we reboot and we're done. Our virtual machine is running. Yay. Hmm. However, it was stored in variable libvert images. That's not where I told it to put things. We're going to have to look into that a little bit and find out what's going on. I think I might be misinterpreting their instructions and doing it wrong. We'll see. But as you can see, I've also got an IP address. Yeah, this is different than my actual main network, so it's running on a virtual LAN within the computer. All right. Yeah. I can create a virtual machine, but I think I'm going to have to look at the instructions a little better and how I should set up the parameters. Yeah, this is not quite where I wanted it. I wanted it to be in this folder. It's not there, but that's a problem for next time. Okay, well, we got it up and running, so in our next video, we'll go ahead and tackle some of these remaining problems we have here. Actually doing this, I think I got a lot better understanding of what the Proxmox was trying to do with their instructions. It may be that I'm interpreting some of these instructions wrong. Say I'll do a review and then I'll do a troubleshooting video as a follow-up to this one. So yeah. So here we are, quite a while later, and yeah, this install of Red Hat's Cockpit was interesting. I didn't have quite as many problems as I had with Proxmox, but there were their share of problems. But didn't want to give up this time. There are a few problems I still need to resolve on this, like for example, my virtual machines are using a internal NAT, and it makes it difficult getting out to my LAN and to the internet. So that's something I got to work on. When I was saving the virtual machines, they didn't go where I wanted. I think I have an idea on why that's happening, and this has more to do with the nuances of the jargon that I'm probably not interpreting correctly, as as opposed to anything wrong with the programs. But I'm planning on resolving those in a troubleshooting post next week. Actually, having walked through this gives me some more appreciation for Proxmox, and it also
indicates to me that some of my problems with Proxmox might be my misunderstanding of the directions I read about it or the jargon I'm not understanding correctly. So, and after I finish playing around with Cockpit here as a hypervisor, I think I'm going to visit Proxmox again because I've got another hypervisor server I want to build. So hopefully you'll be around for that video too. I'll actually record it this next time. All right, talk to you later.